Okay, so let's read through this. Machine designed to put jam into donut settler average of 1.2. The machine is checked regularly to ensure the amount does not deviate from this. So I can see normal distribution mentioned somewhere, right? Assume the amount of jam follows a normal distribution and a standard deviation here, okay? But we've got to be careful, right? Because we've got the mean for the population is 1.2. But we've also got to take account of there's a sample size of 20. So let's go ahead and just draw a little picture. So here's let x equal the amount of jam. And so we've got this for the population, not drawn very well. There's 1.2. And sigma here is 0.1. Now the important thing is from here to here, the sample size of 20. Okay, so down here, this is x bar 20. The sample mean for samples of size 20, and of course this is a lot tighter, a lot narrower. Still distributed around 1.2, but now the new standard deviation for this is 0.1 over root 20. That's the key. So in all of our work, we're going to be dealing with this distribution down here, okay, and not this distribution up here. So that's the important thing to bear in mind for all of these questions. Alright, so let's go ahead and have a little think about this. So we take a sample of size 20 and we want to know, let's see, which direction are we testing for this? What's it say? The machine is checked regularly to ensure that the mean does not deviate from the amount at each of the checks. Okay, so we just wanted to know if there's a change, right? It doesn't say in one particular direction. There's nothing suspected about it being too much or too little. So let's just write down the null hypothesis is that jam is dispensed with mean of 1.2 kilograms. Now, I don't think in any of this question it says that the standard deviation changes, so we'll just leave that as 1.2 kilograms, and the alternative is that jam is dispensed with mu not equal to 1.2. Okay, so I suppose you could just put population mean is 1.2 and population mean is not 1.2. Okay, write down the probability for type 1 error. Well, here's where we've got to remember what is the probability of a type 1 error. Probability of a type 1 equals 5%. Okay, it's just the probability of reject the null given that the null is true. And that's just the critical region. And of course, this is the picture we're dealing with. We've got this picture. This is a 1.2. Standard deviation here is 0.1 divided by root 20, and we set 5%, 2.5 down here, and we set 2.5 up here. Because this is continuous data, we can get exactly 5%. If it was discrete data for binomial Poisson, we might not be able to get exactly 5% for the critical region. Alright then, so let's find the final bit now. Given that the actual amount of jam delivered is 1.17 centimeters cubed, find the probability of a type 2 error. Okay then, so let's just have a look at probability of type 2 error. Equals probability of accepting H0 given HA is true, right? So we're given an alternative mean. Now, can you see accept H0? So basically, what were the conditions under which we accepted H0 on the original hypothesis? So we really want to define this as the acceptance region. So we've got to go back to our original little thing here. And so we're going to go to our TI-Nspire. And I want to find this K value here. And I want to find this M value here. And you can probably see that if I go back to my TI-Nspire menu, probability, distribution, inverse normal, and we're going to put in an area of 0.025. The mean is 1.2. Remember, if the null is true, we're dealing everything to do with the null, the original hypothesis, divided by root 20. There's root 20, right? Make sure that looks okay. Close the bracket. Okay, 1.15. So k is 1.156. And then I can just go up on my calculator, then change this to 0.975 to get the value of m. That's 1.244. 1.244. Okay, so accept the null. That's if x is less than 1.244 but greater than 1.156. Okay, given that the new mean is 1.17. So basically we're drawing another picture down here. We've now got a shift down of the normal curve. Here's 1.17 now. And basically we want to know, here's the k value and here is the m value on our new distribution, and we're just working out this particular area. Alright, so we're going to do a norm CDF. Let's go back onto our calculator. You can see that we're trying to work out a particular area now. We've got it defined down here. Okay, and that's with a new mean of 1.17 between the values of k and m, and we found k and m from before, so let's go ahead and do that. And don't forget the standard deviation down here is the 0.1 divided by root 20, which we grabbed from up here because that hasn't changed. Let's finish this off then. Menu, probability, distribution, norm CDF. Lower bound is the k value, 1.156. Upper bound is 1.244. The mean is the new mean, 1.17, and the standard deviation is 0.1 divided by root 20. Close bracket. Let's have a look at that. And that's 0.734. Oh, let's just put a proper pen on that one. 0.734. Okay, hope that helps.